Hello and welcome to MSc 402, Engineering Project Management. This is going to be your week 3 video lecture. And this week's lecture, this module's lecture, is on project planning and the project planning phase. So let's jump into our model and take a peek at a couple of them. So let's first go to the PMBOK, the PM Book of Knowledge or Body of Knowledge model, and you can see that what we're doing is we're covering the planning phase group, and you can see how the initiating group overlaps into the planning phase, and the planning phase, according to this model, goes almost all the way up into the closing area. You can see it covers also into the executing and monitoring and controlling process groups. In addition to that, you can see also that we have 10 different knowledge areas that are umbrellaed underneath this particular model. Now, let's go into the model that we've created for you for the course. You can see that this is the third module, the third phase. We've gone ahead and completed the introduction phase, the initiating phase, and now we're into the planning phase. So last week, by setting up that scope statement, really getting that project charter nailed down, we're now ready to start putting a lot of what I'll call the structure in place that really becomes what we're going to execute to. So this week we're going to be covering, or this module we're going to be covering, that manual breakdown structure, the MBS. You're going to be putting your project schedule together. You're going to be looking at, once you've got that schedule together, being able to create a bar chart, a Gantt chart, resource loading, and looking at what that's going to look like. Okay, so let's go ahead and jump in. The planning phase itself, as you can see, once again, still has changes that are coming in on the side and quality that's maybe being adjusted depending on what's happening on the project itself. So the planning process group consists of those processes performed to establish the total scope of the effort. So this means this is everything that's going to be encompassed into what we refer to as the scope. We're going to define and refine those objectives that we started on in the last module, and we're going to develop what we call the course of action required to attain those objectives. Those tasks, those subtasks, the milestones, everything that's encompassed in the project is going to be covered in the planning phase. Let's go ahead and jump in and start talking about planning and that project planning phase. So that once you've got the project charter approved, that gives you the funding to kind of move forward. The scope statement gives you the ability to really start to define things, get it kind of worked out, but not necessarily 100%. But when we get into the planning phase, this is where we really need to understand exactly what we're doing. We need to really refine it down into work breakdown structures, really understanding the elements of what we're pulling together and all of the areas specific to this project. That's what we're going to be covering. Now, the planning phase is where the project solution is further developed in as much detail as possible and the necessary steps to meet the project's objectives. This is where we take our tasks and our subtasks and we pull them together. It's also an area where you may start to see some scope increase from what you had originally thought you were going to have. That is very typical, because once you start looking at what does it really take for me to get this accomplished, you're going to see that you have, from a scheduling standpoint, more tasks than you thought you might have. You start to unveil some areas where you didn't really have a lot of what I'll call definition in, and this is where all of that definition is available to you. This is also a good time and a good place to identify stakeholders for each of the areas, because you need to have them either give you potentially more input as to what's accomplished in these areas or what is necessary to get you across the finish line to sell this off. Okay? Let's take a look at what we refer to as a work breakdown structure. This is also called a WBS. You can see that the WBS is one of the major components in what we call project scope management. So the illustration that I have underneath my image is what the PMBOK refers to as project scope management. And you can see that the Create WBS is at the center of it. That's the heart of it. And you can see all of the other activities that filter into it, all the other knowledge areas that are interconnected to it. So the work breakdown structure is almost like the heartbeat of the program. It's the central area where everything is going to be coming into. You're going to be creating what we refer to as a hierarchical plan, and that means that you're stair-stepping your way down into that work breakdown structure. It's going to cover all of the work activities focused on the deliverables. It does not focus on the organizational structure of the project team. Remember, in a previous lecture, we talked about the RACI, which is where we resource loaded it, or the RAM. Okay, so the RAM and the RACI were done in another area. The work breakdown structure is where we really take all of the activities, the elements, the tasks and subtasks, and this is where we map these. This is where we try to make it available for people to really understand and see what we're putting together. Now, I'm going to make recommendations for you for a couple different things that you need to do. One is to create a work breakdown structure. You want to start at the top, and the top gives you a description of what it is we want to do. And I've got a sample for you out there called a Manchester Downtown Hotel Project. So I've actually made this Microsoft project file available to you. You can see it in conjunction with this lecture, but you'll see that in the illustration that we've got over to the side, we're replicating that Microsoft project schedule, and you can see the Manchester Downtown Hotel Project is the major accomplishment. That's what we're calling the project. And you can see that we have acquire property, and under acquire property we've got a subtask or a sub-element called hire a realtor, and another one called find suitable property. Those are two major tasks associated with being able to acquire the property. And you can see that under each one of those major tasks, like hire a realtor, we have a series of subtasks associated with that. It's common practice for the top line of the WBS or Microsoft project file to be the name of the project. That's very, very normal. The next tier down is where the necessary components of the project are listed, and then each subsequent major deliverable that's a portion of the main one will be listed underneath and indented. Microsoft Project will do that for you automatically once you start to load the components in. If not, you will want to go ahead and do an indent on them. Now, if we continue looking at it, okay, if we continue looking at this, what we've entered into Microsoft Project, we can see that we can break these down into finer and finer details. So at this point, what we would do is we would actually estimate the cost and the schedule for the work being done at a higher level. So if we take a look at hiring a realtor, how much would it cost us to hire a realtor? We can look at the subtasks and we can estimate what we think those costs would be. And these may be done at a higher level, referred to as a WAG. And there's a couple different ways to create costs. One is top down, the other one is bottom up. Top down means I'm going to break the project up and I'm going to tell you you're going to get $20,000 to hire the realtor and you're going to get $30,000 to find suitable property. And that I'm estimating that $55,000 is what I'm going to give you money-wise to accomplish these tasks. That would be a top-down version. A bottom-up version might be that I go and I look at all the subtasks and I've got people that know exactly what these cost, and they tell me that the search listings is going to cost $10,000. The short list of properties is another $15,000, and the developed property search criteria is $5,000. So they would say that possibly that find suitable property is only going to cost $20,000. Many times doing that bottoms-up estimate, you're going to find that the costs are higher. Typically, that is what's going to happen because the more detail you have, the more clarity you have on what you think the costs are going to be and the schedule associated with it, the more detail that you have, you're going to find that the costs are going to be higher, schedule's probably going to be lower. I'm not recommending a top-down or a bottoms-up for you for what you're going to be working on, but what I am doing is showing you an illustration as to how to get two different ways to getting not only the schedule and the cost associated with something in the work breakdown structure. Now, activities are at the level where the actual steps or the work of the project exists. So work packages, when we create a work package, Similar to what we just talked about, real estate could be considered a work package, and it could be broken down into sub-work packages. So when we start using the term work package, it means one major breakdown or one major subset of activities required to accomplish the project. Stylistically, they're also intended in Microsoft Project to be spaced further out than the given work package that is typically presented to you. So you're going to see that things tend to indent. The outdents are meant to come all the way out to where you have the major project, and then you start to indent in by work package and then subtasks and potentially other ones. Okay? And this hierarchical structure that we're talking about, illustrated in the graphic below my image, that is very typical of what we refer to as a work breakdown structure. It also can be done in a tree structure, very similar to what I'm showing you here. Now, my way of putting together this initial, I'll call it document that you're going to be working on for the ECS version of your project is going to be broken down into the top level, as we show on the template next to this other image over here. Now, let's talk about two different ways to look at the project. One is the bicycle example that I've got for you. You can see that the level 1 of the WBS is the bicycle. That's what our project is. The next level down, level 2, is where we have the components or the major elements. You could call them work packages if you want. So the frame set is a work package, the crank set, the wheels, the braking system, the shifting system, the integration, and the project management. All of those could be considered work packages that need to be developed or to be blown out into more detail. And you'll see that when we get into the third level of the WBS, you can see how that construction looks. So the frame set is actually broken down into the frame, the handlebar, the fork, and the seat. All of those need some level of work associated with them and assembly to be able to be completed and then moved up into the level 2 WBS to complete that work package for frame set. All of the work packages in the W2 level WBS must be completed for you to be able to sell the product off as a bicycle. Now, if we turn this philosophy sideways, you'll see the template that we've created for you, and it's an Excel spreadsheet. So my recommendation is if you take a look at what we gave you, and by what you got in your project proposal, there were certain things that were requirements for you for the project that you're working on. You automatically inherit the feasibility study, the requirements analysis, the requirement specifications, the procure hardware, assemble hardware, test hardware, and then demonstrate hardware. All of that is part of what you inherited in the project from a proposal perspective. So all of that has been encompassed for you up to this point. Your scope statement has encompassed all of that. You may determine that there are additional things that you need to put in here as far as work packages. So you see 9, 10, and 11 are open. Feel free to add anything else you think needs to be placed into this work breakdown structure. This is what we refer to as the initial draft of the work breakdown structure. And many times what you'll do is you'll delegate different areas off for different people. Somebody from manufacturing may understand the assembling of the hardware better than someone that's a design specialist. So you may have a design specialist work on one thing, an engineer work on another. Manufacturing may take over the assembling of the hardware. Testing the hardware may be a test engineer that comes in and gives you those series of steps. But this is what's referred to as the initial draft, or the initial draft structure of a work breakdown structure. We want you to go ahead and do the initial draft first, and then once we're done with that, we're going to then load that information up into Microsoft Project. So that's how we get that Microsoft Project loaded work breakdown structure. We decompose the information that we had in the manual, I'll call it template. Once you've got that spreadsheet completed, you've got a great template in front of you, then you can start to put this information into Microsoft Project. and refine it. So when you enter it, you'll understand the hierarchical level that you're going to set it up in, exactly like what we've illustrated under my video picture for you here. You can see how everything is indented, how everything is set up from a WBS standpoint in the right numerical order, and you'll start to see that as you lay these tasks out, they automatically start placing themselves in there to a point where you can say, this is going to take 15 days, this will take 30 days, this will take 20, and it'll start to create your schedule for you. Now, the linking of all of these tasks has not happened yet, but what we're trying to do is we're trying to put that representation in Microsoft Project. Once we get 100% of that completed, we've at least got the structure, the bare bones structure for what the project's going to look like. Now, you can also, at this point, flip one of the views around. So we were looking at a Gantt view previously as we had things hierarchically laid out. Now, what you might want to do is you might want to look at a project network, and there's a reason for that. There's network node analysis that can be done, and there's something that you can do in a network diagram that you can't really illustrate or see when you're looking at a Microsoft Project view that is a Gantt chart. The network diagram will show where you have areas that intersect within each other. So you'll have 3 or 4 activities that network down into what we call a choke point. That choke point, that specific point where you must get through it to move on to the next set of points, is typically where we run into areas where we have problems. Resources become constrained at that point, and these are what I'll call natural areas for the project to slow down. We've got to do the handshake. You've got to take one element, finish it up, and hand it off for somebody else to pick it up and run with it. This is where we typically lose a lot of time. Many times on projects, this is also where you can start to see how much slack you have. So there are ways to determine through node analysis what that slack is going to look like. But you'll also be able to see the critical path once you start to click and link these together. So in Microsoft Project, you would just take one activity and say this activity is connected to this one. Use the connection tool and create that flow. We want you to finish off the project so at least you understand from front to back where everything is linked. Linking gives you the ability then to look at what we call the critical path. And the critical path is nothing more than the longest path through the project. So the activities and networks that are created in the node analysis that we were talking about give you the ability to look at the project at a different level. It gives you the ability to also then go in and start to predict where you may be able to save time, or from an illustration standpoint, you can start to see where it may be necessary for you to add some other activities that are going to flow in at different points. So that interconnected nature of a project is really illustrated through the activities and the networks. You really need to understand that. This view is also another one that's great to share with your stakeholders and other people on the team, because it really shows how the whole system is working. That view gives you the ability to say, from a network standpoint, this is how the project's going to go together. All the activity times that overlap, you actually get to see how pieces fit into each other with the flows and the arrowing structure. Okay? Now, let's just talk about some terminology associated with those network diagrams. So you have what we refer to as precedence diagramming method, or the precedence diagramming method. This is where you can start to look at what needs to go in what order to optimize the flow. You also have the precedence relationship, and this is start to finish, or things could be happening at the same time, or things might have to finish before you can start another piece of, I'll call it work. So you can start to see within the illustrations over here, we're starting and we're going into 2 flows. We're working flow A and flow B at the same time. And then to start working on C, you'll see that we have to have element A and B both completed before we can start on C. You have to have B completed before you can start working E. And you have to do E, F, to get to finish, and once you've got C completed, D down into finish. And you can see to finish this project you have to have both D and F completed at the same time or simultaneously to the point where they can filter in or feed into the finish. It doesn't mean they have to be exactly at the same time, but both of them have to be completed before you can create what we refer to as the philosophy for that start-finish diagramming. So these are three different pieces of terminology. Now, when we talk about the critical path, once again, the critical path is the longest path of activities within the network diagram. And you can see that within each one of these tasks, we've laid out the duration. Okay? So the longest path is the minimum amount of time that it would be necessary to complete all of the project work. The critical path is the most optimistic view of what it takes to finish off, I'll call it the project. Delay of any work on any particular area of the critical path, any of the nodes associated with that, is going to impact the delivery date of your project. So in the illustration that we have below, you can see that A, B, C, D, and E is the critical path. In addition to that, you've got splinter activities happening at F and G and H. And the durations there have some flexibility associated with them because they're not on the critical path. So if you had to work something out of order, if you had to work something a little slower or faster to try to gain yourself activity opportunities, you can see that anything that you can reduce on the critical path is going to make the project happen faster. Anything that takes longer is going to delay the activity, and it's going to make your not only your critical path longer, it's going to make your project take longer. So you can see the value of having what we refer to as network analysis or node analysis done off of that view. So the Gantt view gives you that hierarchical structure. It shows you how things are linked piece to piece. But when you start looking at this, it gives you baseline start, baseline finish, latest start, latest finish. You can see how you can manipulate and possibly start something faster or slower to make an impact on your critical path. Now, there's a term called slack, and there's another term called float. Float is, float and slack are the same thing. I need you to understand both of these are positive words. There is nothing wrong with using this terminology. If you use the word pad, padding a project means that you purposely manipulated the length of time that you thought it would take to complete a task so that you could give yourself a backup plan. Okay? Pad is bad. Remember that. Pad is bad. Do not pad when you're putting together the time frames for how long each of these tasks should be. You need to look at it from a purposeful thinking of what is the real truth for what it's going to take. Lay that information in there, because what happens is if everybody, as they're putting their estimates together, adds pad to it, you end up with something that is very, very, it's just unrealistic. It's not going to happen correctly. So you've got to burn that part of it out. And then what you need to do is you need to start looking at what we refer to as slack and float. So slack can be useful for shifting the start of the work activity, especially if you've got limited resources. That means you can move things around a little bit associated with the slack or the float that you have available for you. It isn't that you have to do something on a specific date unless the resources are identified that way, unless you have constraints that say that this must happen on this day or in this particular order at a point in time. You have the ability to kind of delay things or speed things up depending on what makes sense for you. Now, when we start talking about schedule compression, okay, there's a couple different ways that you can do schedule compression. And there's a couple reasons why you might do it. You may have a project that says we must complete on a specific date, and you may be looking at your schedule and you may be saying, well, I'm not going to hit that date. And you may have incentives based on milestones. You may have penalties associated with late completions. there may be reasons that force you to know that I must find a way to do schedule compression. Typically, schedule compression puts you in a position where it's going to cost you more to complete the program or project. And the reason is you're taking resources that you wouldn't normally have working on something, and you may throw a lot of resources at something. That philosophy is called crashing a project. And crashing a project is something that is done, or fast tracking, when it's necessary, only when it's necessary. If possible, you want to run your project completely by the way you've set things up. But fast tracking means that you can look at things and what can we do in parallel? How can I gain some activities? How can I get things done ahead of time so that I can stage them and have them ready for other activities that could come in? Another way to minimize that time is scope reduction. Scope reduction means you look at it and say, if we had to, from a quality perspective, remove some of the components necessary on this project schedule, what could we do without? There is something that happens on projects called gold plating, where people tend to add activities just because it's been done that way in the past. It may not need to be done. So always look at your project and see, is there anything I can reduce out of it? But scope reduction is one of those areas. If you can get your customer or the stakeholders to agree that we're going to modify the scope by eliminating some of the tasks, that is one way to get there. And then crashing means we take everybody that we have and we throw it at the project. That means I may have designers that are working on assembly. I may have assembly people that are working logistics. I may have quality people that are doing multiple activities. There's a lot of different people working, and these are typically not their original tasks to work on, which gives you the ability to have more people working on the project, but these aren't the best people that you would want to have there because these may not be their primary tasks. So crashing is one of those things. If you crash a project, be prepared to see that you may meet the schedule constraints, but your costs are going to overrun. That is a normal activity. Now, let's talk about predecessors. There's 4 different types of predecessors on a project. External. An external is placed within your project by external activities. Some examples include waiting for permits before beginning construction, or the best realtor getting out of town for a week. Internal predecessors come from a project that can also arise. These are within the control of the project team. These are things that you have major control over, and examples of these would be how you want to use different people on 2 different projects. How do you want to balance them if you're sharing them? The other predecessor is what we refer to as a mandatory predecessor. That means you cannot be fast-tracked since they've got to be done in a specific order. That means that I must do this activity to lead to this activity to lead to this activity. Those are mandatory. The next type of predecessor is referred to as discretionary. And it's simply because someone on the team wants it there. That doesn't mean that it has to be there. At the discretion, it means that it can be moved. And it may be more risky, so you may inherit more risk if you move something to fast track it or to move it into another location, but that's the price you're willing to pay. So those are called predecessors. You can see the image that I've got over here, give toast or serve cake. Which of those would you do first? What's the predecessor? Sometimes when you get into looking at the logic associated with how we put a project together, we linked things just because it made sense at the time. Always go back and look and see, are my predecessors really important? Do I have to have this at this point in time? Now, there's something by Goldratt called the theory of constraints, TOCs. And that means that what you're doing is you're trying to design a schedule, and that schedule is set up to where you put everything right in line. Everything is done in a way to where you both reduce the overall operating expenses and increase the production. And that means that you don't have people at a certain point in time until it is necessary to have them there. The 5 essential steps for this methodology are to identify, exploit, subordinate, elevate, and repeat, that continuous loop. of repeating that. You're constantly looking at what are the system constraints. You're exploiting those system constraints, and you're trying to, if there is a problem, you elevate the constraint to the point where we can get it done. You're creating almost like a red tag on activities as they become close to being needed to be done. So what you're doing is you're always highlighting what needs to be done now, 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 now. And it's constantly moving all of the tasks and reshuffling them and saying, okay, this needs to be done now, this, 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 this. So that theory of constraints works off of that methodology. There are many aerospace companies that do their planning this way. They do their scheduling and they resource load against all of their activities based on Goldratt's philosophy for the theory of constraints. Now, I would caution you that sometimes what happens is that can be manipulated. Not that you should, but it can be manipulated. That means that if you're in a pool of resources and somebody else is running behind schedule and all of you realistically are waiting for a resource, if that resource isn't really looked at as to its impact on other things, all the projects could become late waiting for one project to get done on time. So you really have to have a really good understanding of why you're using Goldratt's philosophy, and that it is ultimately taking everything within the enterprise, everything within your portfolio, and moving it forward the way you want. Now, let's talk about variation and common cause variation versus special cause variation. So Edward Deming has got a great series of books out there that you may want to go look at. But Edward Deming gives you information on what we refer to as variation. Common cause variation are potential flaws in the system that are normally there. We understand that. We kind of plan for that. So those flaws are things that we can kind of understand and work through. Special cause variations are things that happen that cause us to stop completely. We can't plan for it. We didn't know it was going to happen. A worker or a machine error, if somebody doesn't come into work, if I don't have a backup for that person, and that person is a quality engineer, and that quality engineer was supposed to buy off 4 or 5 operations in a manufacturing process, and I don't have a backup for them, all of that is going to flow back. That is a special cause variation that is going to hit your schedule. So you need to understand you can only plan for common cause variation because you can anticipate that. Those are kind of the known knowns. When you get into special cause variation, these are unknown unknowns. These are things that happen that will drive you nuts on a project because they will eat and erode at your schedule. There's nothing you can do to kind of eliminate those. What you can do is create plan Bs or plan Cs to where you try to give yourself as much flexibility as possible to try to float in and take advantage of these if they happen. Okay? Let's go ahead and talk about resources. So one of the biggest things that you have access to, and one of the things that is the hardest to manage on a project, is going to be your resources. The resources available within a project are finite. You only have certain people that you have available to you. You only have time to do certain things. These are things that really, really will drive you nuts, because if you don't use your resources smartly, if you don't use them according to the way the project says it needs to get those resources, you're going to increase your schedule, you're going to overrun your costs. So you've got unexpected delays or projects that are terminated due to lack of resources. Those are normal things that happen. You need to understand that you've got to try to balance between the time that you need to get something done and the resources necessary to do that. Those are normal, I'll call it dichotomies, that you have every time you're working on something on a daily basis, because you have other programs, other projects in the loop, and they want those same resources. So unless someone is firmly dedicated to your team, you're probably going to have to pull resources in, because you don't want them there full time. You want them there to do a specific task, and then you want to matrix them off as quickly as possible to save as much money as you can. The challenge from a management perspective is to maximize the most use of limited resources available to them by their teams. Scheduling kind of lays out a perfect path, and what you want to try to do is you want to try to work to that. But remember, there's two different things. Schedules are one thing. Plans are another. Plans give you the ability to understand if something happens, what are the other splinter decisions that can be made. Schedules are driven off of decisions that are made. You're following a predetermined path. You need to be able to create both. And anyone who says that they have a plan and they pull up a Microsoft project sheet and show it to you is only giving you limited information. The plan should be, what happens if this can't happen here? What are the other opportunities that we've taken into account? Risk management, how did we mitigate this? Opportunity management, how do we exploit things that could happen for us? Those are opportunities that become available to make your resources more powerful and more, I'll call it, beneficial for you from a project's perspective. Now, let's talk about that project budget. You get a budget in the beginning of a project. Many times you accept a budget that is very aggressive and you say, we're going to do everything we can to meet that budget, but you need to understand that things happen to you inside a project that you would have never thought. Rates for people, their hourly rates can increase in the middle of a project, which means that it costs you more because of pay rates, rental costs, the expenses of contractors. There's a lot of different data points that come into creating that budget. So you may find, and I would basically tell you that 95% of the time you're going to be working on a project and the costs are going to be going in the wrong direction. You're going to do everything you can to try to hold your costs or minimize those, but that budget that you've got is a finite amount of money, and you need to find a way to stay within the budget, if possible, within each work package. And sometimes if you know that you've blown one of the work packages, but you think you might gain on another, there's a way to balance some of that off. But those are philosophies that you've got to do as a project manager as you're moving through and looking at your project budget. Okay. We talked about estimating methods before, and we talked about bottoms up and top down. So I gave you examples of those when we were working on the WBS. There's another one that's called one point, and this kind of estimation is very simple. It's done on the basis of past projects. That means data-wise, if we've done something similar, what did it cost? And using that as your estimate, rather than trying to do a top-up or a bottom-up or a top-down estimate, what you do is you say, based on similarity, something we did similar in the past, this is how much it costs, that's what I want from a budget standpoint. Now there's also another method called three-point estimating. Three-point estimating is where you start looking at it from an analytical perspective and you start looking at formulas. There are ways to start averaging, ways to start looking at things from a pessimistic perspective, and ways that you can automate this. And they can be done from a three-point estimation, they can be done in a parametric method, and they can be done in a heuristic method. So remember that estimating is an art. As a project manager, you might want to look at a couple different methods before you select one for your budget. You may want to run the calculations for a three-point and then look at it from a maybe not so aggressive perspective. If we gave ourselves a little bit of pessimism, what would that include? And that pessimistic might be a top-down version versus the bottom-up. Bottom-up is always going to cost you more than any of the other methods because you micromanage the cost of every one of those activities. And typically what you're doing is you're taking the cost that's a little bit higher than what you would anticipate and you're floating that out. Okay? Now, closing the project planning portion of I'll call it, of a project really falls in line with a couple things. One, you're going to plan from the day you start the project all the way up until the day you close the project. Closing the project may require planning activities. So you're going to see that this activity of planning that we're talking about here is something that you're going to have to do constantly throughout the execution of the program, throughout the monitoring, throughout the, any of the risk mitigation. All of these activities, these splinter activities that are coming in, are going to require continued planning. So remember, the plan is one thing, the schedule is another. Planning gets updated possibly on a daily basis, updated on a weekly basis. The plan needs to change. It needs to be adaptive. You need to have flexibility into it so that if something happens, you can take advantage and move in multiple directions. Okay? This is the lecture that I've got planned for you. No pun intended on the project planning area. Planning is an art. Microsoft Project is a tool that you put information into. Project planning means that you're communicating with people, and that's probably the most important thing to remember as a project manager. You have to have great communication skills. You need to ask people around you, other people who have done work, how much should this cost? Because if you try to determine the cost yourself and put it together, you're creating an artificial view. Have the team members associated with these tasks tell you how long does it take to accomplish it, what have we done in the past, get lessons learned, pull that in and use that as guidance for yourself. So congratulations, you're into the planning phase. The next lecture is going to be on execution or executing a project. I look forward to seeing you. If you've got any additional questions on this, feel free to contact me. Have a great week. Goodbye.